Hello and welcome to Applied Database 1. In a previous session, we introduced entities, attributes, and relations. In this session, we will continue with the relational model, and after defining entities, attributes, and keys, we will address functional dependencies. As stated before, the selected primary key can retrieve specific record and provide all the values of related attributes. For example, plugging in student ID 12345 will display all attributes associated with the student John Doe, including his email, social security number, phone number, and other information. Basically, student ID is an attribute that was used to determine other attributes in the relation. So the primary key student ID is in this case called determinant. When a value of one or more attributes can determine a set of other attributes, we call it functional dependency. A combination of attributes can be used as determinant. For example, we can use more than one field or one column to determine other entities. In this slide, you can see that student ID as a primary key as an attribute, we call it as determinant, which can determine other values such as first name, last name, address, city, state, zip code, email, social security number, and the phone number. For a combination of attributes, the example will, as shown in this slide, quantity and unit price can provide the extended price for a product or a unit. And this is an example of a composite key or composite determinant. The example in this slide shows that employee or employee number is used as a primary key and is used to determine other values within the table. Employee number can determine other attributes such as the first name, last name, department, email, and phone number. The functional dependencies are not equations. The functional dependency will help identifying the primary key, the foreign key, and related constraints. So writing the functional dependency in this form will allow me to determine that employee number is the primary key or the determinant, which can determine the other attributes within the relation. As we stated before, some of these determinants can be composite, which means that they consist of more than one attribute. And we give the example of the quantity price. The extended price is a result or an attribute that's been defined by the quantity and the unit price. So with this, the primary key for me is the quantity and unit price. Those functional dependencies follow certain rules. For example, if A can determine B and C, then A can determine B alone and A can determine C alone. For example, your social security number determines your first name and last name. So basically, if I plug in the social security number, it can determine your first name alone, or it can give me your last name alone if needed. Another rule, if A and B are needed to determine C, then neither A by itself or B by itself can determine C. For example, the quantity by itself cannot determine the extended price, and the unit price by itself cannot determine the extended price. I need both quantity and unit price to determine the extended price for the number of units or the invoice or the order that we have in hand. Let's look at the following example. The table shown here represents water sports and camping items in a retail store. The table includes a stock keeping unit number, the description of the item, the department, and the buyer's name. We need to identify the determinant in this table, then write the functional dependencies. The determinant or the candidate keys has to be unique attributes that can determine other values within the relation. The buyer's name is not unique since we have more than one person that could have the same name buying from that department. The department name has been repeated multiple times, and the description is long and might contain spelling errors. So from going over this, we can see that the SKU number is a determinant and can determine other items such as the description, the department, and the buyer in that table. Although it might have errors, but the item description can determine the SKU values, the department and the buyer, the description will have information enough to determine those attributes, but still it's not enough to be used as a primary key. From what has been discussed, the SKU as a determinant attributes, it includes numbers and it's unique. The SKU description and the SKU attributes can be considered as candidate keys, while buyer will not be considered as a candidate key due to the possibility of redundancy. From those candidate keys, the SKU will be selected as the primary key for this table. Let's look at another table. In this table, we have the order that's related to the different items in the SKU table. We have the quantity, the price, and the extended price. Now we need to identify the functional dependencies in this table. The order number with the SKU can be used as a composite determinant to determine the quantity, price, and the extended price. The order number SKU will be the primary key in this table. The other determinant that we can recognize is the quantity price as a composite determinant, which can determine the extended price only. Although it's considered as a candidate key, it cannot be used as a primary key for the order item table. Quantity price as a composite determinant can only determine the extended price. Primary keys should determine all attributes within that table. Now let us express in writing the two tables using what we understood from the functional dependencies. With the table name outside brackets, we can list all attributes between the brackets. Then define the determinant as primary key by underlining that key. Then we will create the relationship between the two tables. The relationship will be through redefining the SKU attribute as a foreign key, so we will underline that attribute and we'll make it italic. To make sure that the two tables has the same SKU number and no errors happen, we need to add statements that consider a condition or what we call constraints to ensure referential integrity of the data. The statement will be where order item .sku must exist in SKU data.sku. In some situations, it's very hard to find a determinant that's unique and can determine all the other attributes in the table. At that point, we can add a unique numeric attribute that can be used as a primary key as we stated before. We addressed that type in a previous session and called it as surrogate key. The surrogate key is a primary key that has been added to determine other attributes in the table. Let's look at an example. Rental property without surrogate key, we can see that rental property, we have street, city, state, province, zip code or postal code, country, rental rate. The rental property with surrogate key, we will add property ID. With adding property ID, we can define the specific property that I'm talking about. So it's more specific and more related. And that's why we added that property ID as a surrogate key, which is numeric, unique, and can identify other values that's related to that record. From learning about the keys as determinant, you can see that determinants is a unique attribute in a relation if and only if it determines every other column in the relation. When you have thousands of data points, you cannot simply scroll through each column and define which one has unique values. It can be determined by the data set limitations and must be logically determinant. That will be all for this session. We will continue addressing more about the relational model in another session. So if you have any questions, please feel free to contact me through the provided channels. Thank you and have a great day.